Okay, hi everyone, welcome again to the session 2 about the concept of bioavailability as it is applied in pharmacology. We start there by which we discussed from the session 1 that bioavailability is equal to the amount of drug into systemic circulation over the administered dose. We have seen the graphical presentation from the session 1 about this concept, and we agreed that amount of drug that enter the systemic circulation or is found within the systemic circulation or is available within the systemic circulation is equal to the area under the curve. Hence we agreed that F, which is designated as bioavailability, will be equal to the area under the curve over the D, which is the dose administered. Okay, let's continue. Therefore, the another concept is here. The concentration of drug in tissues is directly proportional to the dose administered. That means that if you administer a high amount of dose to a patient, we expect to have high concentration of drug in tissues, and vice versa is true. But note that the concentration of drug that is found in tissues is equal to the area under the curve, as we have interpreted from the graph from the session 1 of this concept of bioavailability. Hence, we can agree together that dose administered D is directly proportional to the area under the curve. By mathematical, therefore we got that D is equal to K over A is equal to K times AUC, or K is equal to D over AUC. Okay. Therefore, from K is equal to D over AUC, but K is the proportionality sign, that means clearance. Therefore, let's say for the case of intravenous injection, where we agreed together that the bioavailability in the intravenous injection or administration is equal to unit or 1 or 100%. Therefore, here clearance will be equal to F times D IV. IV means intravenous injection or intravenous route. Therefore, it's equal to F times dose administered intravenous over the area under the curve in intravenous route. And we put this at the question number 1. Someone may ask why I have put here F. As I have said that in the intravenous routes, F is equal to 1. Therefore, note that putting F in intravenous route has no effect since its value is 1. Okay, let's continue. Also, let's suppose the other route of let's also suppose you use the other route of administration other than that of the intravenous. Let's say you use the oral route. The clearance will get under this formula will be equal to dose administered orally over the area under the curve in orally administered curve, and we put this as equation number 2. Okay, don't forget I haven't put F here because we don't know the value of bioavailability, which is equal to F in intravenous route, since is not equal to a unit or is not equal to 1 or 100%, so we will not put it here. Okay, therefore equate the two equations above, question number 1 and number 2. We got something like this one. I think we are together. And then if you make bioavailability F as the subject of the formula above, you got something like this one. Okay. Okay guys, let's look about the types of bioavailability. Actually, there are two types of bioavailability, namely there is absolute bioavailability and relative bioavailability. What is absolute bioavailability and what is relative bioavailability? Okay, let's see about this. Absolute bioavailability is the bioavailability that compare the bioavailability of intravenous route and the other route. For instance, let's say oral route. OR indicate oral route. It means here you compare the bioavailability of the drug that is injected intravenous and the bioavailability of the drug that is not injected intravenous, instead is injected other way than intravenous, and you get the formula like this one. Suppose you are comparing oral route and the intravenous route, and you got the formula of getting bioavailability in this one. And a relative bioavailability, this one compare the two routes of administration other than the intravenous. It means here you don't involve the intravenous route as we involved here. Here we use to compare the bioavailability of the intravenous route and other routes, but here we are comparing two routes other than intravenous. We are not dealing with intravenous here. For example, you want to compare the bioavailability of the rectal and subcutaneous routes, or oral and rectal routes. So that is called relative bioavailability. Therefore, let's say you are comparing oral route and rectal route, so the formula of bioavailability will be in such. Okay, by saying so, thanks for listening, and don't forget to subscribe my channel.